All right, let's move on to the next scene. Obviously, being in Maya, one thing that you probably want to do most is render Maya particles. And of course, Krakatoa can render the Maya native particles and the end particles, the newer system. Right now, you're seeing a very simple system which is emitting from pretty much a point particles driven with some fields like turbulence. See here the turbulence and the air field, and some drag. So I was just trying to create a basic system that is moving in an interesting way. And that system doesn't create that many particles, which of course in the case of Krakatoa rendering is not very good. If I go to the Krakatoa settings, everything is set up for volumetric rendering. And if I hit the render button, I'm getting something that's really ugly. I wouldn't be able to use this for anything because I have very few particles, probably around 30,000. I'll go to, I don't know, frame 100. I haven't even cached that system. I'm simulating it on the fly. I hit the render button, and to take a look here, it says they have 34,000 particles. And as I mentioned, that's really not enough for... You can't create solid shadows. You can't really get anything that looks solid. Even if I enable motion blur and use 8 segments with full frame open shutter, it will smooth it out a little bit, but it's still not really usable. What I can do with this is I can also enable the additive mode, which was mentioned earlier, and this will render the particles as self-illuminated points which don't produce an alpha channel, because additive rendering generally is meant to be added on top of other things. This is really good for creating plasma glows. If I go, for example, to the global render values, I can tell these particles, which currently are running an expression that colors them according to their age, which is a feature of the Maya particle system. I can override that color easily by just saying every particle that comes into Krakatoa, regardless of the source, is going to have this color. This is a shade of blue. And I'll hit render, and I'm getting something that is in the color scheme of what you saw in the Avengers, that kind of plasma look. But once again, as you can see, we just don't have enough particles to create a smooth look. No matter how much we're blurring it, even if you would go and try to use the bilinear filter with slightly larger size, it will blur the particles a little bit, but you still get gaps in between, and that's not very usable. One solution to this problem, which has been used also in Krakatoa for Max and by many people outside of the Krakatoa world, is to take an existing dynamic simulation like this and save it multiple times by changing the seed that is controlling the distribution of the particles at the emission time. And if you do that, you're going to get multiple versions of that system that even though individually look pretty much the same, they have minute changes between the original positions of the particles, and the whole history of the particle throughout the simulation is slightly different. If you put them on top of each other, you get a denser cloud. So we have a tool here which already found that particle shape 1 in the scene and proposed to save it. If I had PATs or PAT volumes and so on objects, they will be on the left list because normally you don't save those, but if you want to save them, you can just double click them and move them over to the other list. So right now we are about to save this. We'll be saving it into the default path as version 001 and the prefix plasma, and we have requested 100 variations of this, and we want to save only from 1 to true. I don't really want to waste your time doing this in real time. I'll just show the result after that. And what will happen in this case is, since this is a dynamic system and it has a random seed that controls the emission, we'll be just randomizing on each iteration. We'll be using a different seed, producing different distributions, and we'll be saving position, velocity, and color only, which is the RGB, the velocity channel, and the position channels of the Maya particles. We map internally the Maya channel names shown in the brackets to our own channel names, which are kind of the standard names used for the typical render channels in Krakatoa. So I'm going to hit this Save Particle Objects to PAT Files button, and it will start simulating and dumping to disk. I can go and take a look in the PAT folder. I have a version 1, and you're going to see that files are being written here. And it's up to around 70, almost 200, which is half of the first run. And the file name that you're seeing here is plasma, which was the prefix, then the particle shape 1, the name of the object, and then there is a suffix which says part 001 of 100, because 100 was the total amount, total number of particles that I actually request. I mean, not particles, but iterations that are requested. And then you have the frame counter and an extension PRT, which is our particle format. And after the first sequence of 200 particles, I mean, the particle files was saved, then it does a second run where it saves a second set of files, and in this case they have part 002 of 100. And once it saves all of them, we'll be able to create a PRT loader and load those particles in our scene and render them. I will wait for it to finish. I could hit escape, but I really want to get all 200 from both iterations. And after I do this, at any point I can go and run it again, just change this to 3 and this to 10, and probably this should be 3. And I can hit save again, and it will create 7 more variations, and I can keep on going and adding more and more particles until I get thousands and millions that I need to get the correct result. So let's create a PRT loader. I'll click on the PRT loader icon, and it creates an object in the scene with the familiar settings that we saw when we were looking at the mini. But the difference is when I click here on the load PRT file, and I'll go up to where my PRTs are saved. Here is the folder. I will click on one of any one of those sequences. It doesn't really matter which one, and say open. And Krakatoa actually says the file that you picked appears to be part of a sequence of 100 files, which is what we kind of requested for the final number of sequences. And it says, do you want to load the other ones or just the one that you just picked? And I say, yes, I want to load more than one. The first one got added, but now I get a list of all the others, and I have an option that says show me only the existing ones. And if I do this, I can just select this one and say add the sequence, and it will add it. But theoretically, I can add all 100, even though they don't exist, because I might be saving them right now in the background, or send them to the network to process, or whatever, and expect them soon to be there. So you have the ability to select only what exists, only what you really want. And the other interesting thing is, by default, all the other sequences will be loaded only enabled for rendering, but not for the viewport. This way, if you have 10 sequences, each one has 1 million particles, you don't want 10 million in the viewport, you want 1 million. The first one will be representative in the viewport. All the others will just render, but won't show in the viewport. So I say add, and now I have 2 sequences here. The first one has viewport and render checked, and the second one has only render checked. And that's my system. I'll just hide it. Right now, by default, whenever you create a PRT loader, it shows 10% of the particles. So I'll switch to 100%, and I'll switch them also to display as velocities, so you can see the velocity vectors. This is now the cached version of those particles, and you also see the color that was saved, because we request saving of that, and we'll see the velocity drawn as a line. And if I check the use in viewport option, you'll see that we're actually doubling the density, and they look almost the same, but they're not the same. They cover more volume there. I will switch to my compositing application and open a preset that I had here. Here it is, a comparison. I will start playing this. It probably won't play really well over the software that we're using for the demonstration, but I'll zoom in a little bit and you will see the difference, hopefully. This is one partition rendered with motion blur and some blurring, and this is 10 partitions on top of each other, and you can start seeing how it's filling the gaps. If I especially go to later points where it's more obvious, see there are fewer particles here, and then we get more particles, and you can go with 100 iterations, and then we'll get completely solid. Of course, I was saving only about 35,000 particles. I could have set Maya to save at least 100,000 or even bring it close to a million. I know that won't be very fast, but it's a good idea to have each sequence have as many particles as technically reasonable, and then draw a few versions of those particles. So as you can see in the viewport, we have the display shows that we have on disk 70,000 on this frame. We have in the renderer all those particles, and in the viewport we are showing only half of them because we're using only the one. You can go down to 0 or both. Now at this point I could of course also render, hit the render button, and this will render this frame with both sequences there. But another thing that I can do, I will disable the second one. I will be loading only the first one as it is. Let me go to another frame like this one. It looks like I'm also rendering another thing that I shouldn't be rendering. So let me open here. We don't want to render the Maya particles. We're rendering only the PRT loader. So this is the Krakatoa PRT loader only. And there is a second approach to actually increasing the particle counts. I'll be talking about it in the next minutes in context of another scene, but let's take a quick look. Right now we are blurring the path, so I will switch this one to use 1 filter size. And for render, and these are the particles from a single run, as we saw them in the beginning. What I can do here is I can go and open the other tool that we have in the icons, the Modifier Editor. This is a manager that allows us to add extra attributes to a particle object, including all the PRT objects that ship with Krakatoa, and also the Maya native particles. You can select the system and just add those extra attributes. Right now we don't have any extra attributes, but if I hit this button and say repopulate particles, I get a few extra attributes added here, which behave as a unit, like one entity. We call it a modifier. It's not really a modifier in the sense of what 3ds Max, for example, uses, but we needed a temporary system for controlling things on our particles while we are introducing our node system that's currently in the works. So what this one does is it says, okay, I have this source particle, so one for each one of those particles. I want to register it on a grid and distribute in a certain field radius around it a number of new particles. I'll be doing one subdivision for that size, and I'll be creating one particle inside in each one. And I'll hit the render button and I'll start getting more particles. This is a little bit too diffuse, so I'll go to 0.05. which will make the influence smaller and will bring them together. And now if we take a look at the output here, we're actually producing a lot more particles. If I disable this option and render again and take a look here, instead of 35,000, we are producing 336, which is pretty much 10 times more. And I can keep on going. I can go and just say, I want to create 10 particles for each subdivision there. And this will create about 3 million, I guess. No, I forgot to enable the modifier, of course. So it's doing nothing. Every time I hit, it renders, and I don't even notice. So let's see how that will go. Now this is better. So what you're seeing here is hopefully around 3 million, yeah, 3.36, which is pretty much what we were producing there times 10, because for each voxel we created 10 times more particles. All right, but you're seeing that it's actually getting blurry and so on. It's probably a much better idea to do it with the saving approach as we did before. And in this tool, there is a second set of options. When you have a system that is already baked, that means you have an initial state in your Maya particles and the seed doesn't really control anything. We are detecting when a particle is being born. That means its ID is being added to the stream and before it didn't exist. And at that point only, we can randomize either its position within a certain jitter range or its initial velocity with another value. You can do either one. And that allows you to actually produce variations of systems still being driven by fields dynamically simulated, but having an initial state that you cannot modify otherwise. With this tool, you can actually do that.